Okay, next in our line of discussion about heat transfer comes convection. So we're going to talk about convection, which is heat transfer by fluids, basically. That's hot liquids or hot gases. Okay, so basically this takes advantage of properties of matter that change at different temperatures, specifically one property, which is density. All right, so let's just show you a little bit of what happens here in convection. Basically, if you heat up a fluid, that's either a liquid or a gas. In this case, we're talking about a liquid. So you heat it up maybe with a flame, say this is a pot of water. Then the middle here gets hottest. The middle of the water gets hot, really hot. Hot things, the molecules are more spread out, as we were discussing earlier with molecular theory. As the molecules get hotter, they hit their neighbors harder, they spread out more. Something that's more spread out, if the molecules are more spread out, that means that part of the liquid is less dense. If it's less dense, something that is less dense is going to float or rise. So the less dense hot water by the flame has to rise. It has to go up. All right, so it's going to go up toward the top of the liquid. Notice, as it goes up, it goes away from the heat source, right? This is the heat source down here. It's really hot down here. Up here, not so much, although it will eventually get hot up there as well, but less hot up here because it's further away from the heat source. So it's going to cool off a bit. The liquid cools off a bit when it gets near the top. So then it's going to want to fall back down again because now it's more dense, right? More dense, colder, more dense. The molecules are closer together. So what you get is this convection cell, is what it's called, a convection cell. So it's this convection, this circle of convection, a convection current. All right, so it's going up in the middle, down on the sides, up in the middle, down on the sides. All around this is occurring, all around the pot. That's what's happening when you see water boil. You've got this water going up and down, up and down, up and down, up and down. Just like that in a big circle. So basically, convection happens because hot fluids are less dense than cooler fluids, and they rise. Take note, you could make convection happen the opposite way. I don't have a picture for this, but let's say we were to put a cup of water with some ice. Alright, so we're just gonna call that a cup of water. I know it's a black box, but use your imagination. So we have a cup of water there, and we put some ice in the top here of the water. Alright, this part up here gets cold. So cold up top because of the ice, little ice cubes up there at the top of the water. Alright, so then what happens? Cold is less dense than warm. The rest of this is going to be warmer. A little bit warmer down in here in the water. So what happens then? The water is going to sink because it's more dense. But of course, as it sinks, it gets further away from the ice. So then it's going to get warmed up down here at the bottom a little bit. And then it's going to come back up. And get cold again from the ice. So again, you have this same circular motion. It's just being caused by cold at the top instead of hot at the bottom. So same idea. I'm just trying to show you that it can happen both ways. You can have heat at the bottom, which causes convection, or you can have cold at the top, which causes a convection current. Okay, so here's a demo that we'll probably do in class. But here it is visually in a diagram so that you can kind of get the idea of what's going on here. Basically, convection is defined as transfer of heat from one place to another by the motion of a hot fluid, such as water or air. Now, here we've got a candle and it's lit, so there's a flame. The hot flame is going to cause the air above it to get hot by conduction, right? Conduction because the air is touching the flame there. And then as the air gets hot, it gets less dense. It's going to rise. That's called convection. So the candle flame causes convection. All right, just zoom in there so you can see it a little better. Convection is caused by the candle flame. Okay? Now let's take this smoking wood splint. All right, it's not lit. It's not on fire. There's not a flame here, but there is a smoldering, like, glowing thing there that's producing smoke. So you've got smoke coming off of the wood splint. The question is, what happens to the smoke? And it's very interesting. You're used to seeing smoke rise, but in this sort of a special situation, right, what you have happening is hot air is rising through this chimney. Air has to come back in to replace that. You can't have air just disappear from this chamber and not get replaced. So air has to come back in to replace the hot air that's going out. Guess what? It comes in the cool air to replace the hot air here. The cool air has to come in here. And as it comes in here, it comes past this smoking splint. It carries the smoke with it, which of course smoke is just particles that have little particles of hot ash that have come off from the end of this thing, not even necessarily hot, just particles of ash that are coming off from this splint. And they're being carried by the cool air down into the chamber, across to the candle flame, and out this other chimney. So basically this weird thing, you'll see smoke go down because the air is being pulled in, the cool air is being pulled in through this chimney, and the hot air from the candle is going out this chimney. Cool! And as with the last video, we have a couple examples for you to take a look at, just to orient yourself as to what's going on here, how this applies to everyday life. I forgot to include an example of cold convection, but you might think of a refrigerator, which has a cooling unit on top, or like a glass of ice or something like that. So convection can be caused by cool things being at the top of a container, as well as hot things being at the bottom. Okay, so here, we've got a pot of boiling water. We've already talked about that. It gets hot at the bottom, water comes up and circles around there. Here, we've got a pair of hot air balloons. Hot air rises due to convection, basically. So hot air rises, these things go up into the sky. As long as you keep the air inside hot, you can float around to your heart's content. Here we have a radiator. This is an old style radiator. It gets hot. All this metal here gets hot. And then the air above it also gets hot by conduction, and then it's going to rise by convection. Notice the paper that's floating above the radiator. Why? Because the air is floating up. Air is rising from that radiator, and it causes these pieces of paper to float there. That's cool. All right, here we have a thermal image of, basically we have a thermal image of hot air that's rising off of somebody's hand. It must be a cold day, but you can see basically the hot air is rising. It's a convection current going up from that person's hand. And then the last example I want to show you is actually cloud formation, whether clouds form due to convection. All right, so the surface of the earth is hotter than the air, generally speaking. So sometimes if the sun is really doing a good job of heating up the earth, then you might get this column of hot air that starts to rise. And then if there's enough moisture nearby, it's going to carry moisture up with it. As it rises, it cools off. The moisture condenses, and you get this cloud forming, right? As it goes up and up and up, you can see the cloud would have started more down here and expand and rise and get bigger and bigger and bigger as convection occurs. So hot air rises, and then the water condenses out as it gets cooler, and then, of course, you know, rain might start falling then as a result of that. So there you go, convection. It's the motion of hot or cold fluids. So it's the transfer of heat by the motion of a fluid. Convection cannot occur in solids. So let me just illustrate that. Okay, solids. No convection. Okay, there you go. Only in liquids and gases can convection occur. All right, so it's limited to things that can move around. All right, that's what I've got for you for convection. Stay tuned for the next video about radiation.